goes fast. Unlike a V-gate type operation, when it reaches the end on a V-gate, you have some sort of magnetic structure coming, and then it just stops, right at the very end. This thing blows it out the end. In fact, if I had more track, it would go quite a ways different. So it's enough to bring it back around to the front if this is in a circular or some type of a pattern that will return it, and pull it back into this very weak little field here until it gets up to here and the gate sucks it back in and blows it back out a second time around. That's what should be explored even more than what we've done here. We've beefed up this gate and we added double arches to the rotor, the little rotor R. I don't know what you want to call it. Geez, but it works. It works very, very good. And it proves that Howard was right. And this is really amazing. You can actually get something that just never thought was possible. Newton's law states that F equals ma. In other words, that force is equal to mass multiplied by acceleration. Energy in physics is the ability or capacity to do work or to produce a change. And that's what this device does. I have my pointer here. My chopstick pointer. So energy exists in various forms. It can be converted from one form to another. In this case, it's magnetic force fields to accelerated motion. So, as I was stating before, the asymmetry between the flux density of these cheap little ceramic magnets versus these N52s, and then going through a gate where the actual arch goes through the center area of the gate is what makes this possible. And because of the varying field, that custom modified field, which gives you this curve, you can see the distance between these magnets on the stator and this rotor, so to speak. This is called a linear motor, even though it looks like a car on a track. That's what it is. But work is the exertion of force over a given distance. And in order for work to be accomplished, there must be a displacement in space. That means that something has to be moved from point A to point B, or wherever you want to put point B. So it takes energy to do that. Well, in the Howard Johnson linear magnetic motor, the energy required for such exertion of force is obtained from the force fields of these properly aligned permanent magnets, and thus moving the accelerated mass over a distance from point A to point B in time. That's exactly what this does. So the conclusion of that is that permanent magnets can provide a form of energy so long disputed by physicists, and you can so easily see it done. Watch, I just barely touch the release lever here, just pushing it down just slightly just to release the car. It just shoots out very, very fast and will keep on going with enough acceleration and enough mass of weight to enter back into the beginning and pull it right back through the gate again. I'd like to make one more point perfectly clear. I've got a scale. Let's turn this on. Calibrate itself. Okay. 3.7 ounces. 3.7 ounces. That's the mass that we're talking
be